Hello, my name is Joshua Schouls, and today I'll be presenting my capstone project proposal, the Indoor Greenhouse Project for ELEC 10045 Engineering Applications. I'll be briefly covering what I will be researching and designing, what goals I plan to reach, and of course I will be covering the electrical schematics and physical layout as well. Owning and maintaining a garden is a lot of work, especially if you plant outside. Plants are subject to weeds, animals, and unpredictable weather conditions. It's quite hard to control and monitor a garden which has so many external factors which affect it. Bringing the plants inside allows for much more control over the garden and makes monitoring and control systems a lot easier to implement. There are many variables that can be monitored in a garden, and there are experts dedicated to this subject. After a bit of research, I have narrowed it down to 3 control variables and 3 monitoring variables. For control, I have chosen airflow, which will help with temperature control, light, and soil moisture via the water valve. The monitoring variables include temperature, soil moisture, and then the water tank level. These variables will be adjustable via the keypad and LCD display on the front panel of the enclosure. You will be able to see the current readings from all the sensors in the garden. A computer will also be connected to act as a human-machine interface, and this will be designed in the NI LabVIEW software. Using this HMI, the user will be able to adjust variables, view current or past readings, and more importantly, export all the readings to an Excel file which can be further analyzed. Another thing to note is that since the system is a closed-loop system, control system design and tuning will be required for both the soil moisture and temperature feedback loops to ensure that the system reacts according to the user settings and ongoing changes in the garden. In this multi-line diagram, nearly every wire in the proposed circuit can be seen. 2 temperature sensors and 2 moisture sensors will be used to take readings, and these will be averaged together in the end. There will also be a 12-volt power supply to power the LED lamp, the 12-volt fan, and the solenoid valve. All these components will be controlled by relays connected to the Arduino. The Arduino will really be the central hub for all operations. Everything will be connected to it, and then a USB cable will be connected to a PC running the HMI software. The user can also choose to use the LCD and keypad interface. Zooming out, we can see a bit more clearly how the whole system works together. Here we can see all of our inputs as well as all of our outputs, and we can see how the relays are being used to interface with 12-volt devices. And finally here we can see a side view of the physical layout of the garden. The water tank being on top to allow for a gravity-fed water supply. We have our various sensors inside of the garden, and we have our LCD and keypad on the front panel here. We also have all of our electronics tucked away in the bottom. And this will conclude my presentation. Thank you.